the very basic question is, why do we need this capability? I mean, the world has lived with it. If you think about this, Cisco came up with it in 2017, but then Cisco came up with MDS product line in 2002 or 2003 timeframe. So what happens, right? Like, how could the world live with this capability forever? And the idea is very simple, that the all flash and the upcoming NVMe wave has changed the world forever, right? Like, a lot of us are working with those customers where we are seeing that the storage ports are fully utilized, right? When you send a command to all flash array without even NVMe, right? Uh, the responses are sent at line rate, and the response times are getting in microsecond level. The IOPS promises are getting into millions of IOPS. So all those are great as a lab certified result, but the question is, what happens with our customers? Are they going to get this performance? Because they don't just deploy one storage array and one switch and a couple of servers and test it out, right? There are so many different applications. And most of these applications are legacy applications, right? They're not going to rewrite the whole application stack just because there's new all flash or NVMe stack coming in there, right? So it's very important that we tell them if they're getting that performance, if they're not getting that performance, why they're not getting it, and when things changed, and what they can do to change it, right? Those kind of questions. Okay, so I think I've used this analogy a couple of times that if your all flash array is there, that doesn't mean you're going to get the performance, because our realities are very different. And when I bring that perspective into our overall stack, I want to spend some time here because it's very important. We'll keep on referring to this, block diagram that you see on the left. Essentially, you see those 6 layers. What happens when an application tries to access storage over fiber channel SAN, right? So there are 7 layers. I'm just showing 6 here. There's a 7th layer of multipathing. And that's how it goes through from the application to the file system to the block to this SCSI layer, fiber channel drivers, and then HBA drivers. If you have virtualized your environments, which is very common, then these 6 layers or these 7 layers are duplicated twice. I wouldn't say 7 layers because multipathing may not be working at the VM level, that may be working at your hypervisor level, depending on how people have deployed it. But even if we go very conservative, these 6 layers are duplicated. It's the same kind of complexity on the storage end too. A lot of our customers have multiple storage vendors. Even within the same storage vendor, the architecture of these storage arrays are different. Like if you take the example of Dell EMC, they have Extreme IO, they have Unity, they have PowerMax, and these 3 product line, they have different architectures. So the question is, let's say if you're talking about measuring the performance, where do you measure the performance, first of all, right? Because things are going to be a bit different depending on what metric we are looking at, right? And by the way, we'll go into detail of that, right? Some of the metrics may differ, some of the metrics may not differ. But the point is, where do you measure the performance, right? And also within the SAN, a lot of us work very closely with our SAN, solutions, because that's what we play into. But we still have customers, they are operating their host ports at 2 gig speeds. And by the way, they have upgraded their storage to new all-flash 32 gig. And at times, still we see that these 2 gig devices and 4 gig devices are receiving traffic from those all-flash 32 gig ports. And imagine what kind of issues it leads, right? So this is our current state, right? And this is exactly the reason, we started investing in this direction, that Cisco, just as a SAN switching company, we had all those great features that you are already aware of. But in addition to that, we need to take a leap ahead and provide those answers to our customers, because a fiber channel is a stable protocol, right? There's a reason customers use it. And people don't really complain anymore about their links not coming up, the basic issues. But most of the time you'll hear from customers, hey, you know what, I have the switch, it has been there and it has been working, I don't touch it, but then yeah, I have performance issues. People will use the words like slow drain. Sometimes they have slow drains, sometimes they don't have slow drain, and they just like the word slow drain term and they use it. But essentially there are challenges, right? And that's what we're trying to solve. Uh, yes, and what really happens, because we can't really deny the reality, there are still organization silos, and because of that, we have compute teams, we have applications team, we have storage team. Sometimes the SAN guys are a bit different from the storage team. Sometimes they are not. And, essentially because nobody really knows where the problem is, everybody says it's not my problem. In other words, they say it's your problem, right? So what happens today, if you look at the industry, essentially most of these mechanisms are reactive. That's number one. The other thing is, even though there are tools, and we have been using words like CWARM and AppD, and previously, while titration was still a data center product, there were a lot of thoughts into getting into storage visibility, but none of those tools actually focus on the SAN storage per se, right? And we have great participation here. If you guys have any thoughts on that, let us know, because what I'm aware of, that let's say AppD, it's going to tell you that this application call is taking longer because of storage access, but what happens after that, right? So those kind of things, that for application owner, it's a great thing, but what I was showing on the previous slide, uh, that the gap between the server teams and the compute teams and the storage teams, all those things still exist. The third bullet that you see here, monitoring is not granular enough. If you look at the storage arrays, they provide the metrics, but either they are at long duration, like 5 minutes or longer, or they are not like really granular at a, let's say, LAN level, or let's say an VM level, that kind of visibility. Also, there's no automation. Now, I'm not saying we have automation today, but at least that's what we want to. But that's a major gap in the industry. And also, as I've been talking about, like, there are different organization silos. Now, some customers, they like to close that or fill those silos. Some customers don't, right? Like, they still want to run it separately. So yeah, we have to, build our products to suit all of their needs. Okay, now a few thoughts about, our solution is actually a fabric integrated solution. Right now, a lot of times this question keeps up coming from some customers who really understand this thing, right? That we could have built this solution by hooking into the storage, or, using the APIs. Let's say we could have use the VMware APIs, we could have used the Linux APIs, we could have used the APIs of all the storage vendors, brought all the metrics in a single pane of glass and build the solution, right? That was one approach of doing it, but we are not doing that. We have actually integrated this solution into a fabric itself. And why we are doing it is because of these five reasons. First of all, it's vendor neutral, right? So customers can use, let's say, any server. It can be Cisco UCS. It need not be a Cisco UCS. It can be any host operating system, Windows, Linux. Uh, it can be any storage vendor too, right? Also, it's a unified solution. And what I mean by that is that there are no changes required on the host devices. Now, there are solutions which ask you to deploy some agents on servers. And what we keep on hearing from customers, that there are already too many agents running on our servers. We don't want any more agents there, right? So that's one of a unique benefit, that because we are inspecting the flows in line, we don't really need to install anything on, let's say, Linux or your VMware or your Windows, right? Also, different teams can have their own view, right? Otherwise, if everybody's looking at the same data, and what happens if something goes bad there? Okay, it's not even dependent on the end device type. Kind of similar to the first thing, but it's very different because it's not about vendor now. Even if, let's say, we have customers who have standardized on one vendor, but they still have different types of devices, right? Different version of devices, different, let's say, Linux operating system. When they move from kernel 2.0 to 3.0, things change. So it's none of the fabric integrated monitoring is dependent on those end devices. Also, the monitoring architecture of end device. Now, we're going to talk about these things more in detail, but let me take this example very recently. Pure storage array, very good capabilities, and they report almost same metrics as the SAN analytics that we report. But then when they were reporting, we asked them, hey, where do you collect these metrics? Do you collect these at your front end ports? Do you collect these at your back end ports? Do you account for the the amount of time the frames are spending within your buffer queues and all that, right? So it was very hard for us to get that answer. It's not about Pure, it's not about Dell, but the point is that if you're trying to build a solution based on all these metrics, your answers are going to differ because every product or every vendor has a different architecture, right? So a fabric integrated monitoring, you'll see that we have a consistent view, a single reference frame to look at all these metrics. And also because it's fabric integrated, we can enable it close to host ports or on host ports, which is close to our servers or applications, or we can enable this monitoring on storage ports.
Hey, Paresh, can I jump in for a sec?
Yes.
So one of the things that we hear from customers, and I'm sure everybody knows this, but most of our customers now have a mix of vendors, right? I mean, it's pretty standard these days to have, some Dell boxes, maybe some IBM stuff, some Pure, whatever it may be. Most customers are not standardized on one platform. And therefore, what that really means is they've got lots of different applications that measure things differently. That's one of the things that we find all the time. We get into conversations with customers and they're in this app and it says it does this, and then they're looking at VMware and it says this. And so there's nothing that's consistent and you can't really correlate those things together. One of the reasons why having it in the transport kind of alleviates that, and you get a standard number for every single application for every single storage device that's installed in the environment. So anyway, I just wanted to add that because it comes up a lot with customers.
Yeah, and also the last bullet that you see on the bottom right, imagine we make a solution and we hook into Linux APIs. Let's say somebody has 1,000 Linux hosts. We hook into Linux APIs and we find those metrics. We bring into a database and build an awesome monitoring solution. What happens if one of the Linux hosts becomes a slow drain device, right? Then obviously we can't really rely on its capability to report a metric. It's something like, are you monitoring the monitored device? Is it a self-policing kind of thing, or we are going to have a neutral Overwatch kind of thing, right? So these kind of things get really important at that time, that people are not going to open these solutions when everything is working fine, right? They probably use it like 4 times a year, but at that point of time, they want it to work. But let's say there's a slow drain device and we are relying on that device to report its own health, it's going to be extremely misleading, right? And that's why it's extremely important to have a fabric integrated, architecture, which is sitting outside these end devices, storage or servers